Hello everyone. The compatibility requirements for a military vehicle are endless due to the extreme conditions they have to operate on. We can implement advancements in the military forces by introducing futuristic ideas as per the requirements. So, it's a humble try to design a special purpose vehicle which is viable on land, water and as well as in the air. The name given for this amateur project is AMPHICOPTER. I meant it as the Amphibious Aerial Vehicle. Basically, the means of transportations are designed to face three different mediums: land, water and air. As the science and technology as well as the branches of engineering achieve these heights, the vehicles which can operate on a specific medium are very common and are technologically advanced. The vehicles which can operate on either two medium are also common. For example, amphibious vehicles which can operate on both land and water, flying cars which can operate on both land and air, and some specially designed aircrafts which can operate on both air and water. But the vehicles which can operate on all the three mediums are not so common. As per my research on internet, I found many design patterns and conceptual models, but most of them cannot operate as specialized vehicles in all the mediums. The basic objective of this project is to develop a vehicle that can perform vertical takeoff and landing, propel and hover like a helicopter, move through water like a boat, and travel on land like a car with zero transition lag. These vehicles need specialized propulsion units to operate in corresponding medium and other elements to support its operation. This is an attempt to formulate the design of components of a vehicle in order to satisfy all the conditions as well as possible. A vehicle needed to operate in any kind of medium requires several basic components. The characteristics of each component will be designed by analyzing the operating medium and other performance requirements. Without further ado, let's get down to the basic components of the vehicle in a reverse engineering approach.
To move the vehicle by exerting forces against the working medium, we need efficient propulsion systems for each medium. The next component is power unit, which generates the drive force to power the propulsion system. A transmission system is required to transmit power from the power unit to the propulsion system after needed conversion and modifications. To maneuver the vehicle, that is, to change the speed, altitude, and direction in each medium, we need maneuvering systems. The energy input to the power unit is provided by the energy store or energy source. The auxiliaries, this includes components that support the main components and other elements that add comfort and other additional features. All the components mentioned above are purely mechanical or electrical members. An efficient control system is required as an interface to manage the operation of each member, according to the needs of the operator. To house all these elements and to bear all the forces, we need a rigid frame with external body panels, these elements together termed as structural body. Propulsion systems. The system which is responsible for the movement of the vehicle by exerting forces against the working medium are called propulsion systems. In land, the propulsion unit of the vehicle has to exert forces against the ground in the form of rotational or sliding motion to attain translational motion of the vehicle using wheels, tracks, sliders, compressed air cushions, etc. In water, the propulsion unit has to exert thrust force to move the vehicle using paddles, screw propellers, Sharrow propellers, water jets, air cushions, etc. In air, the propulsion unit of the vehicle need to apply thrust force by means of aircraft propellers, toroidal propellers, rotary wings, jet engine nozzles, duct fans, etc. Power units. A vehicle needs a unit that generates enough power to drive the final drive or propulsion system. The output energy of a power unit is supplied directly or indirectly to the propulsion system. IC engines, gas turbines, steam turbines, fuel cell engines, nuclear power units, electric motors, etc. are some common examples of power units. Transmission systems. Transmission system acts as an intermediate agent for transferring power from the power unit to each propulsion system. This system includes gears, friction plate clutches, electromagnetic clutches, shaft couplings, fluid couplings, etc. The power unit, propulsion system, and transmission system together termed as powertrain. AMPHICOPTER needs three kinds of propulsion systems to operate in air, water, and land. All the propulsion units need individual power input too. The main challenge faces while designing these vehicles will be the drastic increase in the weight of vehicle due to the presence of multiple power units. For example, 3 individual motors are needed to power 3 different propulsion units. The problem here is, the drastic increase in weight will adversely affect the aerial movement of the vehicle, where the weight of the vehicle is a crucial factor. In order to avoid this problem, we have to switch the power to 3 different propulsion systems from a same power unit using simple, lightweight transmission mechanism. Things to consider. The propulsion units, power unit and transmission unit must be chosen and configured in such a way that they can be worked together as a single system. The input power to all the 3 types of propulsion units should be similar, for example, shaft power. The power unit should be flexible to every working condition in terms of torque range, speed range, etc. The power unit should be light in weight, should have high power to weight ratio and high torque to weight ratio. The transmission system should have to transfer power to different propulsion units as needed. Energy source or energy store. To provide input energy to the power units, energy sources are also needed. It is directly dependent on the power requirements of the power units. Things to be considered. Should ensure a decent operating range and operating time to the vehicle. Should have the ability to recharge, refill, or replace. Maneuvering systems. The systems which are responsible for changing the speed and directions of the vehicle are termed as maneuvering systems. Its functions include to control the speed of the vehicle by acceleration, deceleration, braking, etc. To change the direction of the vehicle in each medium. To perform other operations like takeoff, landing and hovering. Things to be considered. The techniques like differential thrust, tank turn and regenerative braking should be added to avoid maneuver the vehicle without excess weight. Design should be intelligent and optimized to achieve this in every aspect. Control systems. Propulsion systems and maneuvering systems are responsible for the movement of a vehicle in a medium, but the vehicle operator cannot directly handle the propulsion systems and maneuvering systems. An interface is needed to input operator's requirements to those final drives. The control system acts as an interface between the operator and the drive units to drive the vehicle as needed. The control system includes operator input unit, vehicle control unit for air, water, and land operation, actuators, different kinds of sensors, accelerometers, global positioning system, onboard diagnosis system, communication system, etc. Units such as flight controllers must make decisions on their own to stabilize the vehicle in windy conditions. Auxiliaries. The system required to support other components of the vehicle and increase the comfort of the operator are called auxiliaries. These include lighting system, suspension system, air conditioning system, seating arrangements and other additional features. Structural body. The structural body comprises of lightweight body panels fitted to a ladder frame, backbone, tubular, or monocoque chassis. The main functions of structural body are: the structural body bears all the stresses on the vehicle in both static and dynamic conditions, to house all the other components in place in a vehicle, to give rigid and flexible characteristic as per the requirements, to provide aerodynamic and hydrodynamic properties to the vehicle as required, to give an aesthetic appeal to the vehicle. Things to consider. In case of AMPHICOPTER, as it need to approach all three mediums, the design of the structure should satisfy all aspects regarding aerodynamics and hydrodynamics as well as possible. It should act like a hull of a watercraft to float on water and like a fuselage when the vehicle is airborne. The structural body should have made of lightweight, stronger materials. When designing all the components of a vehicle, there are many things to consider. The overall weight of the vehicle needs to be reduced through efficient design and use of lightweight and strong materials. Stick to aerodynamic shape by avoiding unnecessary projections to reduce drag force. In each medium, there are many supporting and opposing factors. To maximize efficiency and performance, we must design each member in such a way that opposing factors have to be limited and supporting factors have to be enhanced. Factors affecting stability such as center of gravity, center of buoyancy and metacentric height need to be considered.
The project started with basic design formulations with hand drawings. The design for each components, mechanisms and outline of the vehicles are prepared in rough drawings. In that phase, I plan to prepare only 3D drawings with all the details. But when the journey started, many books and technical contents were referred to in order to get knowledge about all the forces, dynamics and components of various kinds of vehicles. As we were willing to accept the knowledge, it further complicates the matter by providing details about more dependent factors in both static and dynamic conditions. But in fact, it brought the conceptual design into more practicality. So it is always better to stick to the relevant scientific theories and do the design and development procedures.
The basic calculations to conduct feasibility studies had done and prepared a project report with detailed descriptions of all components. All the techniques required for all basic operations including propulsion, maneuvering, speed control and other related operations in each medium are also explained in the report. The detailed 3D drawings had prepared in CATIA V5 software to define the basic design of the vehicle. Repeated cross-checking and refinements made the design of the mechanism simpler and more compact. Several charts and software are used to understand the required parameters of the aircraft propeller. This presentation can be made more attractive and exotic by stating that this vehicle has futuristic features like EODAS, AI systems, advanced fire weapons, etc. But explaining those things would unnecessarily complicate the project. As said before, the primary goal of the project is to design and develop a vehicle that can operate regardless of medium. So, once it is developed, we can re-engineer the vehicle for different scale and purposes like surveillance, rescue, combat vehicles, freight vehicles with futuristic technologies and features.
The prototype of this vehicle is almost impossible to fabricate from my end. It requires more technical analysis at higher engineering level and huge investment. Since it has to operate in air, complex testing and simulations like wind tunnel testing and CFD analysis are required. So it is impossible for a person from a middle class family to build this vehicle. But with the help of the government and concerned authorities, it is possible to make this dream come true. And I truly believe this vehicle will serve our nation through military forces and uplift the pride always. While talking about this project, I am getting excited and emotional at the same time. Looking forward for a great opportunity. Hopefully, signing off.